Good morning. Happy Thursday. We're going to do a quick lesson today, continuing with what we learned yesterday about covalent compounds. So just to review, there is a difference between covalent and ionic compounds. We'll talk about like their inherent like physical characteristics and their reactivity characteristics later. But just in terms of writing and naming, well, first, what they do with their electrons. Covalent share. Yesterday we talked about, you and your friend sharing that pencil back and forth because you both need it. You both, like, hey, we got one, here we go. And ionics are made up of a metal and a non-metal, and covalents are just all non-metals hanging out together. In terms of how you write them, ionics, that's what you have to look up the charge. You have to see if they cancel or do they crisscross. Do you need parentheses? So there's a lot of work in writing covalent compounds. But there's not a lot of work in writing, there's a lot of work in writing ionics. Um, you know, you got to make sure you're looking up nitrate instead of nitrite or this or that. But covalents are completely different. Covalence, all you need to do is you just need to remember a set of prefixes. And I don't care if you look at this chart when you're doing these problems, or if you want to copy it down or take a picture of it. If we were doing this in class, this would be written, I would hand you all a charge sheet that had all of those polyatomics on it, and I'd also put all the prefixes on it. So this is not something I'd expect you to memorize in class. This is something that I would give to you. So don't think of it as like, can I look at this? Yeah, look at it. Unless you're 100% confident that you remember the 10 prefix: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. All right. So in order to name them, we put the prefix first. That's why it's called pre, because it comes at the beginning, prefix. And then we just changed the ending of the last element of our second element. We changed that ending to "-ide". So we didn't change any of the first endings. It was only the second endings that we've changed to "-ide". Okay. So today's lesson is going to be writing and naming covalent compounds. Okay, so writing and naming covalents. Today is April 30th, the last day of April, hard to believe. So let's just start off with an easy example from yesterday. Let's do let's see here. Let's do a random element. Okay. So we have SB5, S10. So remember, these are both nonmetals, or it can also be metalloids. Metalloids participate in covalent bonding too. So we look at it and we say, okay, prefix for 5 is penta. This element's an oldie but goodie. What's SB? Antimony. All right. Prefix for 10 is deca, and the element S, sulfur, becomes sulfide. Okay, sulfur becomes sulfide. Now, we wish this would stay nice and simple, but there's always an exception to the rule. And the exception to the rule is the prefix mono. So we're going to call this the mono rule. Mono never, ever, ever gets written first. Mono only gets written second. Okay. And it's kind of redundant to put it first. The best example of this is this element right here. This is what comes out of your exhaust pipes in vehicles. So this is, if I look, that's a 1. Remember, we never really write 1s. But I'm not going to write it first, so I'm just going to write the element. So that's carbon. But I am going to write it second. And then oxygen becomes oxide. So this element is carbon monoxide. So I don't write monocarbon monoxide. That is redundant. You're not going to do that. Mono never goes first. Mono only goes second. Another example of this, kind of keeping in the same family of elements, we have CO2. All right, are you going to put mono first? No, mono only goes second. So I have carbon. What's the prefix that means 2? Di. And oxygen becomes oxide. So we have carbon dioxide. This is what you exhale. So the mono rule is really the only exception. And some of you might get this wrong a couple times until you're like, oh, that's right. Mono never goes first. So what we're going to do now is we're going to switch gears and we're going to write formulas. Actually, yeah, we'll write formulas first. This is also easy. This is where you don't have to see if things cancel or if things crisscross. All you got to do is look at the prefix. All right, so here we go. Let's write the formula for diphosphorus hexachloride. Okay. So like I said, for diphosphorus hexachloride, you're not going to look on a charge sheet. You're not going to think, what does it have? What does it need? You're just going to write it based on the prefixes. All right. So the first element that I have here is phosphorus. So I put P for phosphorus. What's its prefix? Di. Di is the prefix for 2. Okay, what's my next element? Chloride is really the element chlorine. And the prefix hexa is 6. So there you go. Diphosphorus hexachloride. No crisscrosses, no parentheses. You just look at the prefix. There you go. Okay. What if we had remember, you can pause this video at any time. Like if you don't want to reveal the answer, if you want to work it out yourself, just pause the video and then restart it when I do. So we've got nitrogen trihydride. Okay, my first element is nitrogen. And is there a prefix for it? No. So technically the prefix is mono, but you're not going to write the 1. All right. Hydride is really the element hydrogen. The prefix that becomes the subscript tri is 3. There you go. And that is how you do these. Okay, so what I'm going to do is I'm going to give you guys a couple of each to try. And this is where, when you're done, you're going to go back on the attendance tracker and you're going to say how many you got correct. All right. Okay, so here are the 4 that I want you to name. So copy them down, pause the video, and then try and name them. Okay, so I'm going to reveal the answers to you. You should have paused the video and you should have tried to name them. All right, this guy, we have di, carbon, octa. Hydrogen becomes hydride. Remember, there's no X in hydrogen, so it's not hydroxide. 5. Penta, nitrogen. Nana, bromide. Nothing here, so it's phosphorus. Trifluoride. 2 is disulfur. Nothing here, so it's mono. Remember, mono always goes second. Chloride. Okay. So next, let's go ahead and we're going to write the formula. Okay, so here are the 4 that I would like you to write the formula for. All right, so pause the video, copy these down in your notes, and then play the video to see if you got them right. All right, so you should have copied them down. You should have given them a try. So here we go. We've got diphosphorus. So phosphorus, prefix of di. Hydride is really hydrogen, and hexa is 6. So P2H6. Number 2, we've got carbon. Its prefix is penta, which is 5. Oxide is oxygen. Mono is 1. I don't need to write it. C5O. Number 3, heptasilicon, octafluoride. All right, silicon is Si. Hepta is 7. Fluoride is F. Octa is 8. So Si7F8. Next is sulfur. There's no prefix, so I don't put a subscript. Iodide is I. Tri is 3, so I have Si3. So there were a total of 8 on the attendance tracker. I want you to put down how many out of 8 that you got wrong, okay? So that's your attendance tracker. You're putting down how many you got right out of 8. All right, I'll check in with you guys tomorrow.